Properties of inequality. Let a, b, and c represent real numbers. If a is less than b, then a plus c is less than b plus c. Number 2, if a is less than b and c is greater than 0, then a times c is less than b times c. And the last one, if a is less than b and c is less than 0, then a times c is greater than b times c. Next is the linear inequality in one variable. A linear inequality in one variable is an inequality that can be written in the form ax plus b is greater than 0, where a and b are real numbers and a is not equal to 0. So solving a linear inequality. Let's take a look at this first example. We want to go ahead and solve for x like we would normally do with a regular equation, except we're implementing some inequalities into the mix. So first go ahead and subtract a 7 from the left-hand side, and this will give us a negative 2x is less than, and then we'll have a 12. Now you can go ahead and divide by negative 2, and when you divide by negative, make sure to flip your sign. So we will have an x is greater than a 6. And this will look like this. We'll have an x, and then x greater than 6. And this is known as set builder notation. Okay, and if we were to look at this on a number line, you might have your number line, and then say for example this is 6. Essentially all our solutions will be going this way. Some different examples here. You might have the open interval where you have a going to infinity. You might have a to b, or you might have negative infinity to b. The key here is that it's an open interval. You might have a or b right here, and then finally b going to negative infinity, which means open interval, it doesn't include that specific number. It's an open interval. Other intervals we might have, you might have a closed portion for a and b, and then an open portion for your negative infinity to positive infinity. Or you might have a closed interval. For example, your solutions go from a to b, including both of those numbers. Or you might be excluding a small portion inside of them where you're going from negative infinity to a specific number on both sides. Last one is all real numbers, or negative infinity to positive infinity. So key to remember, open, when we have these, you might include infinity or negative infinity, or when you see the greater than or less than signs. When you have a closed interval, you'll use these square braces, and also when you have the less than equal to signs, like this example. So let's go ahead and solve another one here. In this case, we want to solve 3 minus 4x is greater than or equal to 2x plus 8, and give the solution in interval notation. So let's go ahead and solve this for x. First thing we'll do, write out our equation. And then we want to isolate our x and also our constants. So let's go ahead and subtract a 3 from the left-hand side. That gives us a 4x is greater than or equal to 2x plus 5. Then go ahead and subtract negative 2x, which will leave us with a negative 6x is greater than or equal to a 5. Now divide by negative 6. And since we're dividing by a negative, you want to make sure you flip your sign. So x is going to be less than or equal to negative 5/6. And we also want to give this in interval notation. So let's think about this. X is less than or equal to negative 5/6. So we know that we have a less than or equal to, so we're including negative 5/6. and then it's going to be any x value that's less than that. So any x value less than negative 5, 6 is going to keep going on to negative infinity. And we'll go ahead and use the open interval notation here with that parenthesis. Another example, we want to figure out what the break-even point is. So if the revenue and cost of skateboards is given by R is equal to 4x and C is equal to 30x plus 5,250, where is x the number of units produced and sold, and at what production level does R at least equal C? So at least equal to C is going to be a key word that we need to remember here. So let's go ahead and set up our equation. First things first, it says that we want to figure out what the break-even point is, and we have R and we have C. So R is at least equal to, so that means it's greater than or equal to C. And then we can go ahead and plug in our given equations here. So R, it's said in our story here, is equal to 4x, and that's greater than 30x plus 5,250. Similar to previous problems, let's go ahead and solve for x and see what we get. So isolate your x's, and this gives us 15x is greater than or equal to 5,250. Divide by 15, and you'll end up with a x is greater than or equal to 350. So x is representing our solutions here. We know that they're greater than or equal to 350. So we start at 350, and anything bigger than that is going to be a solution as well. So in this case, that would be infinity, and we can put a parentheses there. Solving a three-part inequality. It's not too bad. All we need to do is again solve for x and isolate our constants on both sides of our equation here. So let's go ahead and start with the 8 here and add that onto the right and left hand sides. So this will give us a 9 is less than or equal to 6x, and then less than or equal to 12. Now divide by 6 on both of your sides here, and we are left with 3 halves less than or equal to x, and then less than or equal to 2. Now if we were to write this, since we're having our less than or equal to's, make sure you use your square brackets here, because we're including 3 halves and 2 as solutions. If it were just like this, say 3 halves less than x, which is less than 2, you would use regular parentheses like this. Now, let's look at some quadratic inequalities. Now, these are going to be written in the form of ax squared plus bx plus c, and you have a less than symbol here, but you could also have a greater than, equal to, or a less than, equal to, or a greater than. So some steps to solving our quadratic inequalities. Number 1, solve the corresponding quadratic equation. You might be using complete the square, you might be using your quadratic formula, or you might just be able to factor it out. Identify the intervals determined by the solutions of the equation, and then finally use a test value from each of the intervals to determine which intervals form the solution set. So we'll go ahead and take a look at an example here of solving a quadratic inequality. So let's see, we have x squared minus 2x minus 15. Let's go ahead and try to solve this. This one looks like we might be able to factor it out. So let's go ahead and try to factor it out. We need 2 numbers, in this case, that multiply to negative 15, and when added or subtracted together, gets us this negative 2. That's going to be a 5 and a positive 3, because negative 5 times 3 gives us negative 15. And then negative 5 plus 3 gets us this negative 2. Now, set these equal to 0. X will be equal to negative 3, and x will be equal to 5. So we're not quite done here. What we want to do is plug in some values to see what our actual interval is. So you can go ahead and make a table like this. We'll say these are our try values, and then our value, and then finally we'll have true or false. So some try values, we'll say negative infinity to 3. And then also negative 3 to 5. And then finally, we will have a 5 to infinity. Values, we can pick any value within these specific intervals. So just make sure the values that you pick are within those intervals. So we can pick a negative 4, a 0, and then a positive 6. And essentially what we're doing is taking these values, plugging them back into the original equation to see if it actually makes sense or not, to see if that's a value we want to include in our solution. So let's go ahead and plug this back in. Negative 4, just plug it back into your original equation. Negative 4 squared minus 2 times negative 4 minus 15. And see if that's less than or equal to 0. That will give us, in this case, let's see, a 9 is less than or equal to 0, which does not make any sense. So that negative infinity to negative 3 is not going to be a solution that we want to include in our notation here. Let's go ahead and try 0. 0 squared minus 2 times 0 minus negative 15. And let's see if that's less than or equal to 0. So that will actually give us a negative 15 is less than or equal to 0, which makes sense, right? Negative 15 is less than or equal to 0. So this could be a potential solution. Just double check your last one and see. 6 squared minus 2 times 6 minus 15, is that less than or equal to 0? Well, that gets us a 9 again, and that's not less than or equal to 0. So we have negative 3 to 5, and one other thing you need to do, check to see what your inequality sign was. So ours is less than or equal to, so we want to use our square braces. And that should be our solution for that question. Now we'll look at 3x squared minus 11x minus 4 greater than 0. So again, we can go ahead and factor this one out. So 3x and 3x, you can factor it out a different way if you'd like, but in this case I'm going to multiply the 3 times the negative 4 to get us negative 12. So we want two numbers that multiply to negative 12, and when added or subtracted gets us the negative 7 or negative 11. So we'll have our numbers of negative 12 and positive 1, because that'll get us the negative 12, and then the negative 11. Go ahead and reduce it. And now we can go ahead and set these equal to 0. So x minus 4 equals 0, and 3x plus 1 is equal to 0. So we'll be left with x equals 4, or x is equal to a negative 1/3. Last thing to do, go ahead and test your intervals and see which ones make sense to include in your solutions. Okay, so again, we'll go negative infinity to negative 1/3. And the reason I did negative 1/3 first is because that's smaller than our 4. So then we'll go negative 1/3 to 4. And then finally our 4 to infinity, and just pick some sort of value within that interval to test. So we'll just go negative 1, 0, and 5 and plug this back into our original equation to see if it's true or false. So we'll have a negative 1. Let's see, a 3 times negative 1 squared, and then minus 11x, or 11 times negative 1 minus 4, and we want to see if that's greater than 0. So this will give us a 10 if we reduce, which is indeed greater than 0. So go ahead and circle that one for later, and let's just test our other ones to see if they make any sense. So 3 times 0 squared minus 11 times 0 squared, or just 11 minus 4, and see if that's greater than 0. That'll get us a negative 4 greater than 0, which does not make any sense. So this one is not going to be included. And our last one is to test this 5 value. See if that is greater than 0. This will give us a 16 greater than 0, which does make sense, so we'll go ahead and include that one as well. So notice how we have a greater than here, so we'll go ahead and use our parentheses. So we have two things here. We have negative infinity and we have negative 1/3. And then we want to go ahead and do a union of 4 to infinity. And that'll give us the solution to that particular question. So finding the projectile height. If a model rocket is launched from the ground level with an initial velocity of 144 feet per second and its height s in feet is t seconds after launching, and that's represented by s is equal to negative 16t squared plus 144t, when will the object be greater than 128 feet above the ground? So let's go ahead and set this equation up and see if we can solve for the t to see when it'll be 128 feet above the ground. So we have negative t squared plus 144t, and we want to see when that's going to be greater than 128. So let's go ahead and simplify just a little bit and go ahead and subtract the 128 to get it onto the left-hand side, so it's a little bit easier to work with. And you'll have greater than a 0. And now we can try to solve for this t squared. First, let's reduce by negative 16 to make it a little bit easier. So this will give us a t squared minus, since we have a negative right here, minus a 9t plus 8. And then we will have a less than a 0. And the reason we have a less than now is because we divided by a negative, so make sure to flip your signs here. Now, we want to go ahead and solve for t. So we can actually factor this one, and we want two numbers when multiplied together gets us this positive 8, and when added or subtracted together gets us this negative 9. So let's go ahead and try a negative 8 and a negative 1. Negative 8 times negative 1 gets us a positive 8. And then negative 8 minus a 1 gets us the negative 9. So we should be good to go. And we can set these equal to 0 to give us some t values. So we have a t is equal to 8 and a t is equal to a 1. So let's see if we can go ahead and try some intervals here and some values here to see which one we should use. Should we use 8 to 1? Should we use negative infinity to 1? Or should we use 8 to positive infinity? So our intervals, we have negative infinity to 1, and we have 1 to 8. And then finally, we have 8 to positive infinity, and then some potential values we want to try. And finally, our true and false, plugging it back into our original equation. So let's go ahead and pick a 0 because that's less than 1 and it's within this interval here. We'll pick a 2 and then finally a 9. And let's go ahead and plug these back into our original equation, which is going to be the negative, let's see, this one right here, this t squared minus 9t plus 8 less than 0. So we will have a 0 squared minus 9 times 0 and then plus 8 and less than a 0. That'll leave us with an 8 is less than 0, which actually doesn't make sense. So we do not include this interval, and we can move on to the next one. So we'll have 2 squared minus 9 times 2 plus 8, and we want to see if that's less than a 0. So that will give us a negative 6 is less than 0, which makes sense. So potentially we can include 1 and 8 as our values, and then finally 9 squared minus 9 times 9 plus 8 less than 0, and that will give us again an 8 less than 0, which doesn't make sense. So we will not include that interval. So our final solution is 1 to 8 for our intervals when our potential rocket is going to be 128 feet above the ground. So if we think about the rocket going up 128 feet above the ground, it's going to go and say this is our 128 feet level. At these specific times, say for the first time this is 1 second, then you have 2 second, 3 second, 4 second, and the rocket's going to start falling down, right? It's going to fall all the way down, and then say finally it hits 8 seconds. So this entire time it's going to be greater than 128, and then finally 9th second we're below 128 feet, which is why we only have 1 to 8 as our solution. Solving rational inequalities. Here's some quick steps to do this. Step 1, rewrite the inequality so that 0 is on one side and there's a single fraction on the other side. Step 2, determine the values that will cause either the numerator or the denominator to equal 0. Step 3, use test values from each interval to determine a solution set. So let's go ahead and look at this example. We have 3x plus 1 divided by 2x minus 3, and that's all less than 4. So first things first, let's go ahead and see if we can simplify this just a tiny bit. Go ahead and subtract that 4 from the right-hand side onto your left-hand side. So we'll have a 3x plus 1 divided by 2x minus 3 minus 4, and that's now going to be less than 0. And if we want to go ahead and try to get this whole thing divided by 2x minus 3, let's go ahead and do some math here. So 3x plus 1 and then 2x minus 3. If we want to go ahead and subtract the 4, we need to have a like bottom. So we can subtract the 4, but we also need to multiply 2x minus 3 and also 2x minus 3. And this right here, the 2x minus 3 divided by 2x minus 3 is essentially 1, which is why we can do this. So now, since we have the common bottoms here, we can go ahead and subtract them together. That leaves us with a 3x plus 1 minus 4 times 2x minus 3 And this whole thing is going to be divided by 2x minus 3. Multiplying out, the 4 times the 2x and the 4 times the negative 3. Let's see what we get. We get 3x plus 1 minus 8x plus 12, all divided by 2x minus 3. And this will simplify down into 13 minus 5x, all divided by 2x minus 3. So we can go ahead and take our numerator, set it equal to 0, and then take our denominator and set it equal to 0. So we're left with a 13 minus a 5x equal to 0, and then a 2x minus 3, that's also equal to 0. When you solve for x, you're left with x is equal to 13/5, or x is equal to 3/2. Okay? And now we want to plug in some values for our intervals and figure out which ones to include and which ones to exclude. So go ahead and draw your table, and you can put intervals, and you can put values, and then finally true, false when plugging it into your original equation. So our first interval, we have negative infinity to 3/2, and then we have 3/2 to 13/5, and then the last one, 13/5, all the way to positive infinity. And for some values, we will pick 0, 2, and a 3. Plugging this back into our original equation, we have 3 times 0 plus 1 divided by 2 times 0 minus 3, and we want to see if that's less than 4. That'll get us a negative 1/3 less than 4, which makes sense. So go ahead and circle your interval here for later, and then move on to your next one. So we will have a 3 times 2 plus 1 divided by a 2 times 2 minus 3, and we want to see if that's less than 4. That actually gets us a 7 less than 4, which doesn't make sense, so this interval will not be included. Last one we have 3 times 3 plus 1 divided by a 2 times 3 minus 3, and we want to see if that's less than 4. Again, we'll get a 10/3 less than 4, which actually does make sense, so we can go ahead and include that interval as well, and we can go ahead and write it out. So negative infinity to 3/2 union, or 13/5, all the way to positive infinity.